James. He does all our programming. I'm going to now have a quick chat with him and explain what we've done to alter the design for your needs, and then what he's going to do using the design that we went through in the offices. He's going to transfer that to the machine, and then we're going to put the sample.
This is the big machine? The
big machine, yes. Right. The big noisy machine. Okay, James. So what we've done is we've simplified the industrial version of this case. And we've removed.
So on this machine now, you can start sort of programming the changes and stuff, and that's where sort of, this is what does the actual.
Yeah, this is the machine's interface. Yeah. It's kind of a less glamorous version of what we're doing upstairs.
Yeah.
A lot more 2D. What Jamie's now doing is checking the corner radiuses that we put on to make it look a bit smoother. And just whilst James is doing that, if I can explain, we have a number of processes with the machine. As this is a 3-axis machine, it only mills from a vertical position, and the piece is in a solid place, which means that generally machines will go through a minimum of 3 up to 4 rotations at a time, so there can be up to 3 or 4 programs per job. The first job we'll do is the main body of the job, all the islands that we showed, where the cooling is makes contact with the gates, and that also includes the features. The second is where we finish the top and again add some more nice little features. And finally we add the rear and the front switch, and then the unit will be... We can do a simulation of the job. Now this just shows us how the machine is actually going to act. So the first screen you'll see is a solid stock of material, and it will show a simulation of the tool coming in.
Right, so that's the solid block. So that's the drill going down and starting to
make the main footprint.
So with the simulation, then you can then get an idea of what's going to happen.
Exactly.
Yeah.
It shows you in realistic terms what's going to happen, and it's handy for mainly catch things like possible collisions of tools and things. But really, it just gives you that extra confidence.
So that's the actual
right.
starting point. That's what the unit will be made out of.
Yeah. This is a standard stock piece for that size of material. Now the part's in, we can set the job off. So now we're going to begin cutting the first stage. He'll just give that unit a quick clean off, and we can have a look at it after the...
So sort of half an hour later than we're starting now, we're just, it's done a lot of the intricate work now.
Yeah, it's done all the sort of time-temp stuff. It's now simply doing the front and the rear features.
So now you can see the fins that we just, you know, that were there before.
Yeah, which is quite important for this design.
And that's the curves that we specified early on the design.
Exactly. So now we're going to do the third stage, which is the...
Oh, right, yeah. Put all the holes in now for the everything else. It won't take too long, a couple of minutes to do that.
This is quite a quick.
Yeah. Look at that. So that's absolutely perfect.
It is.
I mean, you see some PCs don't even do like a aluminium foil type back on them that never quite fits to the ports, but that's absolutely spot on.
This one's been made to measure.
Yeah.
There's another little thing you may have seen on the job that it actually threaded a hole here. Now this little hole here we use as a retainer clip for the power supply cable, just for that extra bit of security.
Oh, good idea, yeah.
And reliability, of course. So now we're going to do the final stage on the shooting, which is in front, so we can actually mount the button.
Right. So will it go through the calibration again?
It does.
Every time you take something out, put it back in, it'll be recalibrated. So that's the place the power switch.
That's not the place.
Before, yeah.
I'm just sorry, I actually threaded the power switch as well.
Oh right, yeah. I don't. The camera can see that, but there's a sort of a thread in there.
Yeah, so the
it's not just a hole.
No, it's screwed straight in on this one.
Excellent. That's really good.
Straight for mounting as well.
Yeah.
So now what will happen, you know, we'll go through its final stages of testing just to make sure it goes together once it's had a clean up.
Yeah.
And then it will go to be anodised.
Right.
And upon final testing, it will be an anodised so it's going to go into mass production.
Right. So what's the next stage that we're going to look at now?
Next stage we'll look at now is putting together the complete system.
Right.
And we'll do that into our production shop with our production system.
So, right, okay. This is the machine that make the block or eggs block. So now you've got it back, it's a different colour. What's that?
Okay. We've now anodised this in-house. We've got anodising facilities in-house. We use it for samples for turnaround time. So it's been anodised in the matte black finish. Yes, again on the video, on the 3D designs we did earlier. So now we're getting a really good idea of how the system's going to look.
So when you say anodised, what does that actually mean? That gets the colour on it?
It gets the colour on it. It actually gives the material a finish. It cleans out any imperfections. There's quite a number of steps. One of them is etching, which actually cleans out any imperfections and also gives it the finish. At the moment, you see it's not got a very reflective finish. It's quite matte, and that's the finish we're looking for.
Yeah.
And it also puts the material in a state that it can accept to dye, which is how it's come out of this colour. As you probably know, you can't paint straight onto metal. You don't get the kind of finish we're looking for. It actually makes the surface quite soft, almost like a diamond hard sponge almost, which can actually absorb colour and ink, which is what it's done here.
Right. So the next thing now is to take that over to the...
Now it goes to production.
Manufacturing, yeah, production area. Okay,
now
let's
it's
go
the
there.
production department. Jamie's actually going to put this first system together for us.
Right.
As he actually puts all the samples together,
Yeah.
because he's a machinery, he knows most about them. So
you've got a motherboard, processors, RAM.
yeah, we've got all the items. That is the MSATA device, this very small one here.
Right, that's tiny, isn't it?
It is, and it's very quick as well, and it's great because it keeps the profile of the unit very small.
Yeah.
And that's actually 40GB of storage, one, I believe. So it's plenty for the applications you're going to be running. And then we've got a stick of memory as well, which is 2GB again, we spec'd up earlier. And the motherboard is a i3-2100T.
Right.
So Jamie's going to start putting that together. Probably noticed on Jamie's wrist as well, he's got a blue band with the yellow wire. That's actually our ESD control, which is to protect all the components from static shocks. So on these little spaces, there's actually been a little pocket drill for them, so they actually drop into a pocket. And this is just, again, to get the unit's tolerances very close. I believe they're made out of, is it carbon fibre, these? These washers are actually made out of carbon fibre, so they can't be. They can't actually be suppressed, so they're not there to be compressed or anything like that.
Yeah.
But it stops any metal contact coming to the PCB.
Yeah, because because of the nature of the design, you've got to have the CPU on the case, and there's no room for sort of, or you can't have it loose or anything.
Screwing down the 4 screws that actually hold the CPU pressed to the island, as she calls it. Now these have actually been cut to a certain height to actually put a lot of pressure on the CPU to increase the heat transfer. This screwdriver we use is to get the torque settings just right, so the screws are at the right pressures.
Right, so you're not over tightening it or too much. Yeah.
Now, different models of boards have different levels of torque depending on the pressure that we need to put down on the CPU.
Right, so that tool is calibrated for this board and this combination, right?
Now the unit has its base on, it's now ready for test. As you can see, it's looking a lot more like what we saw in the pictures earlier.
Yeah, and you've got the feet on there as well.
If we lift it up, you can see the gold feet as well.
Yeah, excellent.
So it's very close to what we had earlier. And now we take you through to our test department for a better test.